Phys- Physics Part 82. It is interesting to note that in engineering, the tightness of nuts and bolts is often stated as the maximum torque to be used when screwing up the nut or the bolt. Spanners used for this purpose are called torque wrenches because they have a scale on them to indicate the torque that is being applied. We've got an example for you. Calculate the torque. Calculate the torque produced by two forces, each of the magnitude of 30 Newton, acting in opposite direction with their lines of action separated by distance of 25 centimeter. Torque is equal to force into separation of forces, 30 into 0.25, distance in meters, 7.5 Newton per meter. Now it's your turn. The torque produced by a person using screwdriver is 0.18 Newton per meter. This torque is applied to the handle of diameter 4.0 centimeter. Calculate the force applied to the handle. The principle of moments, a meter rule may be balanced on a pivot so that the rule is horizontal. Hanging a weight on the rule will make the rule rotate about the pivot. Moving the weight to the other side of the pivot will make the rule rotate in the opposite direction. Hanging weights on both sides of the pivot is shown in the figure. That means that the ruler may rotate clockwise or an anti-clockwise, or it may remain horizontal. In this horizontal position, there is no resultant turning effect, and so the total turning effect of the forces in the clockwise direction equals to the total turning effect in the anti-clockwise direction. You can check this very apparatus in the figure as well. When a body has no tendency to change its speed of rotation, it is said to be in a rotational equilibrium. The principle of moments states that for a body to be in rotational equilibrium, the sum of the clockwise moments about any point must equal the sum of the anti-clockwise moments about that same point. Example, some weights are hung from a light rod AB as shown in the figure. The rod is pivoted. Calculate the magnitude of the force F required to balance the rod horizontally. Sum of clockwise moments is equal to 0.25 into 1.2 plus 0.35 F. The sum of anti-clockwise moments is 0.40 into 2.5. By the principle of moments, 0.25 into 1.2 plus 0.35 F is equal to 0.40 into 2.5. 0.35 F is equal to 1.0 minus 0.3. F is equal to 2.0 Newton. Now it's your turn. Some weights are hung from a light rod AB as shown in the figure.